So this is 3/8 to the power of 0. Ending to the 0 power is
1.
1.
Mhm. Right.
1 is almost always a good choice. 3/8 to the power of 1 is
3/8.
3/8.
Mhm.
Then we'll go to power of 2. Not as good, but we need 5 points, unfortunately, so we're going to have to do this.
Mhm.
You square the top, you square the bottom.
Mhm.
9/64.
Right.
All right, that's the easy part.
One.
Maybe
Yeah.
it didn't feel easy, but that supposedly is. Going the other direction now with negative numbers. Okay,
Mhm.
so negative means 3/8 to the -1 power, just like we did before. That means to
Mhm.
flip 8/3.
Mhm.
-2 is 3/8 to the -2 power means to flip it. 8/3 squared. Then you square the top,
Okay.
square the bottom.
So I think what I was doing was I wasn't flipping them originally. I think. Yeah.
It kind of depends on whether you flipped it and left it
Mhm.
as -x or
Mhm.
not. I mean,
But I'm
they're
realizing I just wasn't flipping the 8/3
good. Oh,
just
good.
from previous examples. Yeah. Okay.
All right, so make sure you graph that line as well.
Mhm.
I'm happy to follow your work if you want, but this
Mhm.
is it.
Okay. Yeah. I will share my screen. This is what I have right now. Like that.
Looks okay to me.
Yeah. Yeah. Okay. And
All right. I'll snip this one, and maybe better because it doesn't have a fraction inside. Not really
yeah.
sure, but okay. So one of the ways, let me let that load up there.
Mhm.
There it is. One of the ways to kind of rewrite this, I think, might be useful is that negative is really, it's really like do the 3 to the x, then negate it.
Okay.
And so we're going to follow that recipe here
Mhm.
when we do this. So we're going to start with 0.
Mhm.
It's 3 to the 0,
Right.
which is 1.
Mhm.
Then we're going to negate it.
Mhm. So it's -1.
Yes.
Okay.
With 1, it's 3 to the 1, which is 3.
Mhm.
Then negate it.
Mhm. -3. Mhm.
2, 3 squared, that's 9.
Negative.
Then negate it.
Mhm.
Okay, those are supposedly the easier ones.
Mhm.
Now go to -1. 3
Mhm.
to the -1 is 1/3. Is that, do you
Yeah.
want some explanation? Okay,
Yes.
but then you negate it.
Mhm. So it's -1/3.
Yes. -2 is 3 to the -2, which is 1/3 squared.
Which is 1/9, which
And
is
then you negate it.
okay. Okay, I'm getting it. Okay.
There is another way to do this also. There's patterns here. I don't know if you noticed this, but as you move, you're dividing by 3, if you go backwards.
Right. I see that. Yeah.
And then if you go the other way, you're multiplying by 3.
Mhm.
So there's a few other ways to sort of check the reasonableness of your answers.
Mhm. Yeah. Okay. So, and then I'll share my screen again. So will y always equal 0 in this case?
Because there's nothing added to the -3 to the x, or then yes.
Mhm. Oh, I think I missed a point.
Yeah, looks like you only got,
This is -1, 0, 1.
looks like you're missing -2, -1/9 possibly. There it is.
Oh,
Uh,
yeah. Here, I'll just try again. I'll put the asymptote first, horizontal. Then we have -2, 1/9, -1 over, where did I write that? Over 3. 0, 1, -1. No, that's wrong. It's supposed to be 1, -3, and then 2, -9. There we go. Yeah, that looks
That
better.
looks better. Yeah.
Yeah. Okay, and that.
All right. So let me grab a snip of this.
So here we have like a negative and a negative x.
Yeah. Yeah.
Yeah.
The full, with everything going on here. Right, there it is. Again, what I would recommend is a rewrite here. First rewrite is just the part inside parentheses. So it'll be 2/3 to the power of x,
Mhm.
and then bring the negative down.
Okay.
Is that okay?
Yeah, that makes sense.
All
Yeah.
right. So we're gonna make a table again here. Make a
Mhm.
little more room. X and then Y. Always start at 0.
Right.
So this is 2/3 to the 0 power.
Mhm.
Then negate it. That negative comes all the way at the end. 2/3 to the 0 is 1.
-1.
-1. Then we'll go to the power of +1,
Mhm.
which is 2/3, but then it's negated.
Mhm.
2. 2 means to raise it to the power of 2.
Mhm.
2 squared over 3 squared, that's 4/9, but then we negate it.
Right. Okay, got it.
Now go in the other direction,
Mhm.
unfortunately. 2/3 to the -1 power means to flip reciprocals. That's 3/2, but then negate it.
Okay.
-2 is 2/3 to the -2 power. Flip it, that's 3/2, but it's squared now. 3 squared over 2 squared.
Mhm.
Running out of room here, but it's 9/4 negated.
Get it. Right. Okay, now I get it.
Same asymptote. It's still y equals 0.
Yeah, got it. Okay, that makes much more sense. Just plug these in. Okay, and then I'll just share my screen again. Yeah, that looks correct. Yeah, I think it looks good.
I like it. I didn't see how you, but and it looks reasonable.
Yeah.
There it is.
Okay. And then, okay, that, yeah, okay. Now I was stuck on these.
Got it. Graph the log. Okay, 2 points. That's good.
And then draw the asymptote and then domain and range. So it's like 2 steps.
Cool. All right, share screen. Here we go. Let's start with the domain and the range. The range for logarithms is always -infinity to infinity. These are related to exponentials. I can show you that after this if you'd like. There's a way to easily remember like which one's all real numbers, which one's not.
Okay, yeah.
But that's the same every time. It's always the same. I was, what's always the same? Because that's kind of what you're asking before. It's like, yeah, it's always the same.
Yeah.
The domain comes from what's inside parentheses, which I've drawn there with the logarithm. So you have to set that part greater than 0, like whatever's inside there. Like let's say it was x-1 inside there, would be x-1 greater than 0. On a number line, what that means, it's all the numbers to the right of 0. So 0 to infinity.
Yeah.
Like that. So that's domain and range.
Okay, right.
To do the xy for the log, all right, so the first x value that you always choose is the one that matches the the base.
Mhm.
So this becomes -1 minus log base 4 of 4. Since the bases are the same, there's this property log base b of b is 1. When they're the same, this part with the log becomes 1. So this equals -1 minus 1.
Mhm.
And I'll just color code that here, shade that in case you want to look at that later. But all of this becomes the 1.
Mhm.
So this becomes -2.
-2, right.
The next number you choose is whatever makes the part inside the parentheses, which I've conveniently deleted again, whatever makes that 1. So in this case, just 1.
Okay.
So this is because it matches the base. This is because the inside part is 1.
1. Mhm.
All right, and here's why. -1 minus log base 4 of 1.
Mhm.
Log doesn't matter, the base of 1 is always 0.
Right.
So this becomes -1 minus 0. If you choose any other numbers, you don't get anything that works nicely, and you won't be able to answer the problem correctly.
Mhm.
And so thankfully, this one just asks for 2 points.
Mhm.
There are your 2 points, 4, -2,
Mhm.
1, -1.
Got it. Okay. And then, or I'll share my screen again. So now that I have these 2 points, like,
Oh, I'm sorry. We also need to draw the asymptote.
oh yeah,
So the asymptote is x. It's a vertical line at 0. And I'll explain that. That's the other one. Yeah, that one.
right.
That's 0.
Mhm.
And then the other one should grab. There it is. That looks right.
Okay.
All right, let me grab a snip. I'll do the same thing. This one's a little bit more challenging. Okay, so just going back to the last problem, the thing that I did not do, come on, load up, there it is I did not do the asymptote.
Mhm.
The asymptote is x equals, and then the number, it comes from the domain right there.
Got it.
All right, so we'll do a better job here giving you all of the little pieces here for this one.
Mhm.
All right, so here we go. Domain, I'm sorry, range is always -infinity to infinity. You don't have to think about that.
Right.
The domain comes from setting x plus 2, whatever's inside parentheses,
Mhm.
uh,
Equal to 0.
greater than 0. Yeah. So you solve this and you get x greater than -2. So on a number line, it means all the numbers to the right of -2, but not including.
So -2 to positive infinity. Yeah.
Good.
Uh-huh.
Is that clear?
Yes, that is clear.
Great. Now the asymptote, which I should have done, that surely should follow from the domain, is x equals -2.
Mhm.
It's whatever that first number is there.
Got it. Yeah. Okay.
So you're gonna see something like that.
Mhm.
Now on to this business of the choosing the points very carefully here.
Mhm.
All right, so the work. All right. All right, so the first number you choose is whatever makes the part inside the parentheses equal to the base,
Mhm.
which is 1.
Mhm.
This becomes log base 3, 1 plus 2 minus 3, which is log base 3 of 3 minus 3. Wow, a lot of 3s.
Mhm.
Okay, just like before, log base b of b is 1.
1. Mhm. So now it becomes 1 minus 3.
Yes.
-2.
The next number you choose for x makes the part inside parentheses equal to 1.
Mhm. Which would be wait, so the base is 3 or
You don't care about the base anymore. You just want the part inside parentheses to equal 1.
1.
So you're setting x plus 2 equal to 1, solving for x.
Just -1.
-1, yeah. So this is log base 3, -1 plus 2 minus 3. Log base 3 of 1 minus 3. The reason you want that is the log of any base of 1 is always 0. Excuse me, so this becomes 0 minus 3 or minus 3.
Okay. Okay, I'm getting the hang of it.
Yeah, it's a hard recipe to follow, but you're more than capable of doing this. So I'm happy to do the next one as well. I know it's important that you get through this.
I can attempt the third one, but yeah. Oh, and this looks good. Yeah. Okay, yeah, I can try this one here. So we'll know that the range is always -infinity to positive infinity, and then the domain is 0. So this would be 1 to positive infinity. And we know that x is going to be 1. And then log 2. So when I first pick the points, could I start with just 1 for x?
You want x minus 1 to be 1.
1.
So it's like what value makes that?
Oh, 2.
2, yes.
Yeah. So, 2. So then would that be written as -1 plus 0 because anything to the power of 1 is 0?
No. Yeah, this is where the confusion is. Let me try to explain the intermediate steps here again. The other stuff looks good. You got your line there, so let me share my screen.
Yeah, so I understand the principle of we want to have whatever the bases cancel out first.
So you want the log base 2 of 2.
Right.
Do you agree with that?
Yeah, because we want.
So that means you want x minus 1, which is the part inside parentheses, to equal 2. So if you add 1 to both sides, x is 3.
Oh, okay.
So that's where you put 3 in for x. Oops. And it becomes log base 2 of 3 minus 1, which is
2.
Yes. Just move some of this over. So that becomes log base 2 of 2, which is 1. That's your y.
So 3, 1. Yeah.
The next thing you want is log base 2 of 1. So it's how do you get x minus 1 to equal 1?
2.
2. So it becomes log base 2, 2 minus 1, log base 2 of 1,
which is
0.
Okay, that makes sense. Okay, share my. Okay, yeah, that looks correct. I graphed that. Okay. Then I'll switch to some review I want to work on.
Okay, sounds good.
Okay, let me go to assignments. Okay, I will see. Okay, I'll share my screen. Okay, I just want to like review some of these. So I was like going through like the notes, but I want to make sure that this looks like correct.
Yeah, good. I mean, this is great. You're trying it on your own, trying to figure it out here. All local minimum values, those are the y values, and you do have those correct. And then where they occur are the x values, and those are also correct.
Okay. I guess that's one I wanted to work on. Clear, like, yeah, I feel like I kind of remember how to do these, but still kind of stuck.
Right. Well, you're choosing the ones that are more difficult, so that's a good sign. That's
yeah,
you're not
yeah, the ones I have blanked here are like ones I know I can do, but then I wrote down the ones that I'm like, I like need to clarify these.
Yes, good. All right, there it is. You're seeing my screen.
Yeah.
So the first one here, it really says f. It's multiplication. You're taking f of x and you're multiplying g of x. Sometimes you can do this like this is x squared plus 5x times the square root of 3x plus 1. There's nothing more to do, but you do need parentheses around the first one to show that it's the whole thing of that.
Right.
So for as far as domain, you kind of look at them separately. So you look at f of x first, and you're like, well, is there any issues, like any restrictions? And really, there's only two things you're ever looking out for: is division by 0, which you don't have because there's no division in the first one, and then square root of a negative, which you do have in the second one. So the first one has no restrictions. The second one does have a restriction. You have to set the part under the root greater than or equal to 0.
Greater than or equal to 0. Okay. Right.
Because it can be 0, it just can't be negative. So x has to be greater than or equal to negative 1/3. If you need to, a number line might help. You know, there's negative 1/3. It's a filled in bubble. It's everything to the right of that. Everything to the right of that is good. Filled in bubbles are brackets. Like this.
Okay, yeah, I do remember that.
That's the first part. Let me know when I can move on to next one here.
And then just the top equation where it's f times g, it's just you're just writing it out as is.
Yeah, if they could be multiplied, you would, but this one you can't.
So you just write it as is. Okay, just write that in really quick. And then when I do the square root of 3x plus 1, should I also put that in parentheses? Or
since it's already under the square root, it's like implied that it's its own thing.
Got it.
If you don't on the left, it's as if you're only taking the 5x times the square root, and it's really both.
Right. Okay, got it. Yeah, okay, we can move on to the addition part.
Right, so the next one is f of x plus g of x, which is x squared plus 5x plus square root of 3x plus 1. No parentheses needed. You're just adding three functions together.
Right, and you still can't like simplify it further.
Nothing you can do there. Thank goodness. You look at them individually, like, is there any restrictions? Yes, again, with the root. I can't say that it would always be the same, but it is the fact that, you know, you've got this to the right. So that's bracket negative 1/3 to infinity.
Okay. Okay, that's actually pretty simple.
That's good. Good to hear that.
Yeah. I think like Alex, it just gets confusing because they set them all up like in that box and then they list like g of x, h of x, and then like I'm getting confused by what it's asking, but I know I have to read it, but
this is good.
Yeah, so I guess I'll just share this one as well.
Sure.
Because this is where I'm also, because like asking to find the compositions.
So these are a little different. They're kind of the next step up in difficulty from the previous one here. Let me grab grab this and we'll take a look at it together.
Mhm.
All right. Here we go. There it is. So G bubble G of X really means G of X.
Mhm.
Take G of X
Mhm.
and put it back in there. So you're going to take this X
Mhm.
squared plus 3 and put it into, you're putting it into the X.
X, yeah.
So that becomes X squared plus 3 squared plus 3. It says to simplify your answers as much as possible, which I take to mean you have to expand that binomial.
Yeah.
Unfortunately. So make sure you write it out. It's a binomial times a binomial.
Mhm.
And then you're going to FOIL.
Mhm.
So that's X to the 4th. That's the F
Uh-huh.
plus 3X squared plus 3X squared plus 9 plus 3.
Mhm.
Okay.
Yeah.
X to the 4th plus 6X squared plus 12.
Mhm.
That's your answer for the first one. And thankfully you don't have to do domain and range, but
Yeah. Okay, got it.
all right, so the next one, H of X.
Mhm.
Okay, so that means to take 4 over 7x,
Mhm.
and wherever you see an X,
We're putting it back in.
yeah, and this, if you give yourself plenty of room to write with, you know, make your fraction bars really big.
Mhm.
Don't try to squeeze it, because
Mhm.
sometimes you get, oh, okay, I kind of see what happens here.
Mhm.
This is 4 over 28 over 7x.
Mhm.
You might say, okay, I see that 28 goes into 7. Just gives me the 4.
Mhm.
See, they actually canceled over here on the left as well. You have 4 over x. You can multiply by the reciprocal.
Mhm.
The numerator is really 4 over 1 times x over 4.
Mhm.
And you can see that everything except the x cancels.
Right.
So just x.
Okay. Okay, I remember these, yeah. Okay, yeah. Let me find the next one. And then, okay, I'll share my screen again. This one I was also something like this. I kind of am rusty on this one too.
Okay. Let me all right, sorry, I forgot to share my screen. There we go. All right, for the real valued functions, fx g of x, find the composition. So f bubble g means f of g of x.
Mhm.
You start with the inside one,
Mhm.
and that goes in wherever you see an x. So there,
Got it.
and then
Okay.
also there. So it's 2x minus 3 plus 6,
Mhm.
2x minus 3 plus 5,
Mhm.
2x plus 3, 2x plus 2.
Mhm.
That's your function.
Oh, okay, that's pretty simple. Okay.
To
Mhm.
find the domain of the composition area, first thing is you look at the original g of x, the inside one, and you look and see, are there any restrictions?
Mhm. And we look at the denominator for
Yeah,
that.
well, g of x, you have g of x is nothing. So you just look at it and you're like, oh, there's no restrictions. Great. Then you go to the new one
Mhm.
and look at it. Are there any restrictions on the new one? And you cannot divide by 0. So you set the bottom equal to 0.
Yeah.
And you find that x equals -1, that's a restriction.
Mhm.
It's really that it cannot be -1.
-1, yeah.
So on the number line here, you've got, everything but that.
Yeah.
So in terms of your answer, it's -infinity -1, union -1 to infinity, like that.
Got it. Okay. Okay, that makes more sense. Okay, and then I'll share again. Okay, and then yeah, these ones as well, because I know I did really get stuck on them.
All right. So try the one on the right. The one on the right's a little bit more clear.
So I know like absolute maximum, it's always going to be like this value.
Yeah, does it have a max? And yes, it does. And
It
so
does.
this is asking for the y value.
Mhm.
What is the y value there where you were pointing?
That's going to be 5.
You're giving me the x value.
That's the x,
Oh,
right?
I'm sorry.
4.
No, you were giving me the y value.
Yeah,
I'm sorry.
4, yeah, 4,
Yes.
5. So 5 is the y.
Yes.
Mhm.
And then same question, does it have a minimum? Does it have a bottom?
Yeah, because it
And
stops here.
and what's the y value?
That's going to be a -4.
I agree. Okay, now the one on the right, what's the highest point? And that asymptote there on the left,
So like up here.
keep going left. Keep
So
going.
like it goes,
Keep going. All right, now what does that arrow mean right there?
it just means like infinity, like it just keeps going.
So it goes up forever and ever
Right.
and ever.
Mhm.
There is no max because it goes up forever and ever,
So
which
that's
maybe is
kind
counterintuitive,
Mhm.
but there is none.
Yeah, which is none. Okay,
Yes.
yeah, I heard that.
Okay. The minimum, the minimum, keep tracing until you find them. It's right there.
This open circle.
But there's nothing there, right?
Mhm.
So it does not have one.
Mhm. So it's also none
Yes.
because it's the open circle.
Yeah. It's like
Okay.
looking at a, bottomless pit. It's like, where does it go? I don't know. Just there's nothing there.
Mhm. Okay, got it. Okay, I have another review quiz that I want to switch to.
Sure.
We have like 2-parter quizzes, but oh, this is refresh. Assignments. Okay, yeah, I guess we can start with this one. It's also similar to what we've been doing, but
Composition. Yep.
so this is what we're gonna plug into for x.
Yeah, in both the top and the bottom.
Bottom.
And probably the simplifying is the
Rough part. Okay.
yeah, it really is not ideal.
Mhm.
All right, let me grab a snip here and
Okay.
like you said, you're going to take that there and there. So when we write it, let me actually write it over f of g of x, that 11 over x over 11 over x minus 1. Now, I naturally write big. I would hope if you're not writing this bigger, please do give yourself plenty of space.
Yeah.
This one, though, I'm really going to change it into 1 over 1.
Mhm.
1 over 1. And I'm going to make a common denominator. So the common denominator is x on the bottom.
Mhm.
So I'm going to multiply the top and bottom by x here.
Mhm.
So this becomes still 11 over x up there, but it's 11 over x minus x over x.
Mhm.
The numerator is still 11 over x, but the bottom becomes 11 minus x over a single x.
Mhm.
Is that okay?
Yeah, that makes sense. Yeah.
Now you can multiply by the reciprocal.
Mhm.
And on the bottom, everything cancels, and that's always the case.
Mhm.
In the top, the x's cancel.
Mhm.
And you're left with 11 over 11 minus x.
Okay.
Anything you need me to clarify on that before we move to domain?
No, I see it. It's just like a lot of like canceling out, but it makes sense.
Okay.
Yeah.
When you look at the domain, you first look at the original, which is the inside one, the g of x, and it's 11 over x. Are there any restrictions on this?
No.
X cannot be 0 because you cannot divide by 0.
Bro. Oh, yeah. Yeah.
Okay, so that's our first restriction.
Okay.
The second thing you do is you look at the new function,
X
which in this case is 11 over 11 minus x. Does this have any restrictions? Is there any place where this is division by 0?
So that means like if we put 0 in for x.
No. Where does the bottom equal 0? Where does 11 minus x 0?
Isn't that just 11?
Yes.
Yeah.
So here's our two restrictions. X cannot be 0 and x cannot be 11, but everything else is okay.
Got it.
So this one's got a little more in terms of the interval notation. Minus infinity to 0, union 0 to 11, union 11 to infinity, like that.
Got it. Okay, gotcha. So to clarify, we look at the new function and then the original one.
Yeah, prefer you look at the original first, and then the new one.
Got it. Union. We got it. Okay, let me pull up another one. Yeah, this one's a little easier. This is like different one, but I just wanted to clarify because it's like silly. So I just put 0 in, so it let me fill in. But
yeah, so you first thing is like, does it open up or down? And it opens down because it's a negative in front, so that has a max. That looks good. Where does the minimum maximum occur? That's based on the minus b over 2a.
Yeah, which I did.
Which appears to be 4 over -4, which is at -1. Great. And that's from the next box. There's putting -1 back in for x.
And that would be negatives where
So you're going to square first, then multiply by -2.
Which is -2.
Okay, and then it's 4 times -1, +4, -2 plus 4
is 2.
Yes.
Got it.
Okay. And hang on a second. Does that x equal?
I put x.
Do you have to put that in, or did it ask for? Did it like say x equals?
I think it said, or yeah. X
okay. All right. Yeah. Okay.
Yeah.
Cool.
And then these word problems that we did.
Uh-huh.
I would get confused when it would ask, because sometimes it would just mean like this number would be like the b value would be the answer.
Yeah.
So, like what it's asking, but in
this problem, it's asking for you to find the y value of the vertex, because the y is the cost, and you get that from finding the minus b over 2a and then putting that back into the original. Do you want to try that, and I'll check your answer here?
Yeah. Or so I get so this is where I do the b over
yes, 2a.
Over, yeah.
Yep, and I've got that, so if you want to tell me that whenever you got it.
Yeah, I'm just blanking. It's b is over the -2 over 2a.
Yeah, I mean, use the calculator there, right? The b is -78, so you're going to negate that. I mean, I'm happy to show you this. Do you want me to show you it?
Yeah.
Okay.
just for refresh, because I have just been working on logs for the last like 3 weeks.
Got it. Yeah. Let me jump on here. All right, so these are always in this form, ax squared plus bx plus c. Can you tell me the value of a, b, and c?
Yeah, so a is 0.3, and then b is negative 78, and then c is 21,665.
Perfect.
Mhm.
Now the first thing is minus b over 2a. And this was like, hey, go to your calculator. There's no reason for you to do this. 2 times 0.3. So will you calculate that for us, please?
Yeah. Just use 78. And that's 130.
You got it. So that would be, if this were asking like how many cars were made, that's the number of cars that are made. But to get the cost, you have to put this back into the, so you're finding C of 130. Plugging this in.
And that would be 13,046. That's what
I got a different number, but possibly I made the mistake.
Here, I can try again.
And I will as well.
Plus, yeah, that was my mistake.
Okay.
I'm finishing it.
So on the test, may a good idea to always do the calculations twice.
Yeah. Yeah, okay. Yeah, that was my mistake. Okay. Okay, got it. Okay, and then I just have like one last one that I need clarification on. It's really simple, but I'm just blanking when it's just asking when the zeros are these two values.
Okay, let me grab a snip of that. All right, so here's the little bit of explanation. So you got to be careful of the difference between zeros and then what are called factors. So a zero of minus 13 corresponds to the factor of x plus 13. So this is the zero. This is the factor. Same thing for -3. This corresponds to x plus 3. So the function f of x here is the product of the factors x plus 13 times x plus 3. And you will have to FOIL this. X squared is 3x. So x squared plus 16x plus 39.
Mhm.
Now just really quickly, because it doesn't really address it here. Like, let's say the factor was like +2.
Mhm.
That means it goes along with x minus 2.
Mhm. Right.
Let's say at a factor of 0, that would be x minus 0, but you just write x for that.
Got it.
So it's always opposite in sign.
Mhm. Okay, I think that's all I have for today.
Oh, great.
Yeah.
All right. Let me
Yeah.
go ahead and stop the recording here.